Did y'all have a good lunch? Yes? What do you got for me, sir? Oh, you need a paper still? Always. All right. So today we're going to start off with linear functions review. We're going to review things that you know, but you might have brain dumped over Christmas break. We all brain dump things over Christmas break. So linear functions. And today we're going to start talking about forms of lines or linear equations. So the two common forms, the forms that you should remember and are pretty used to seeing are slope-intercept form and point-slope form. So I'm going to start with slope-intercept form. Y equals mx plus b. Someone tell me what m means. We've already talked about that. Yeah, m is my slope. What does b stand for? It's the y-intercept. So I'm going to draw a little arrow here that says this is my slope. Whoops. And this is my y-intercept. When we say the word intercept, what does that mean exactly? When we say it's the y-intercept, it means what? It's where it crosses the y-axis. Good vocabulary. Okay. The other form that we're going to talk about is point slope form. The reason point slope form is fabulous is because you only need to know the slope and one ordered pair. That x sub 1, y sub 1 is just a point on the line. And that's exactly what it says. It's just a point on the line. Okay. So if you are given a question that says, hey, write an equation for a line that passes through the point 2, 3 and has a slope of 7, you can use point slope form. I like point slope form because it requires the least amount of work and the least amount of thinking. And you can transform that into any other form. Okay. So we're going to just jump right into it. And we're going to look at exercise number 1. It says, consider the linear function. And it has something crazy up here. It has f of x. I don't understand that f of x. What does that mean? What does it mean when I see f of x versus y? Say again, Bryce. Yeah, f of x and y are the same thing. These are the exact same thing. And exactly what Bryce said. He said, we use f of x because it tells us that we're going to plug something in. So this 0 is f of 0 is the same thing as saying let x equal 0. So I take this equation, f of x equals 3x plus 5, and I'm going to replace the x with the number 0. So I write f of 0 equals 3 times 0 plus 5. What is 3 times 0? Okay. And 0 plus 5 is? So f of 0 is 5. So this question says determine the y-intercept of the function by evaluating f of 0 or by letting x equal 0. Why does this give me the y-intercept? What happens when we cross the y-axis? That's what intercept means. We cross the y-axis when, yes, you cross the y-axis when x equals what? 0, yeah. That's an important idea. I would say that that's the whole idea of this little example is that you cross like the x-axis, or sorry, the y-axis or the y-intercept happens when x equals 0. So now we're going to take that same concept of letting x equal 0 and we're going to prove that b in the form g of x equals mx plus b, b is the same thing as the y-intercept. We're proving that b is the y-intercept. So we're going to, again, let x equal 0. So that way we can find the y-intercept. So what does that look like? If I'm going to let x equal 0, what does that look like in this function? What should I write down? I'm going to replace the x with a what? A 0. So I have g of 0 equals m times 0 plus b. Good job. And what is m times 0? Say it loudly. 0. It's 0. Yeah, good job, you guys. And what is 0 plus b? B. So g of 0 equals b. Meaning when x equals 0, you find b. And that's our y-intercept. So when x equals 0, you find the b, the y-intercept. Do you guys remember doing that last semester? Do you remember? Yes? Okay. I'm going to wait a second because I see some of you are still writing. Okay. Raise your hand if you need more time with that. Okay. Let's move on. So exercise 2 or example number 2 says, consider a line who has a slope that is 5. So I'm automatically, when I read slope is 5, I'm automatically going to turn that into symbols. What symbol do I use for slope? M. So I'm going to write M equals 5. Okay, M equals 5. And it passes through the point -2, 8. This is just the point on the line, right? It's the point on the line. So think about point slope form. We labeled this the x sub 1 and the y sub 1. So I want you to put that below the ordered pair. -2 is your x sub 1 value, and y, or 8, is your y sub 1 value. So we're going to take the information and plug it into this equation. So y minus the y1 coordinate, which is what? 8, equals m. What is my value of m, or my slope? 5 times the quantity x minus my x1 coordinate, which is what? Minus, I'm going to write it like this for a second, minus -2. That looks kind of ugly. Minus -2. Is there a way for me to fix that? Yes. What, Bryce? Let's do like plus plus. You do plus plus? Okay. Can I show you what I do? I know that minus and negative is the same thing as plus, so I just turn this minus negative into a great big plus. Like I just make a giant plus. Just one plus. And that's it, right? So I'm going to rewrite it so you can all see it. So y minus 8 equals 5 times x plus 2. So this is in point slope form. All we did was plugged in the slope and the ordered pair. No brainer. That was super easy, right? But now, in our second example, or part B of this question, we have to take that point slope form and we have to make it look like this. Y equals mx plus b. So basically we have to take this and solve for y. That's really what we're going to do. So what do you think we should do first? I'm going to rewrite our equation. Y minus 8 equals 5 times the quantity of x plus 2. What should we do first if we want to get y all by itself, or we're solving for y? There's something we should do before we add. What do you have, Savannah? It is distribute the 5. And I'm going to show you how I show you. Like the symbols that I use for distributing, I always take an arrow and I draw it from the outside of the parenthesis into each term inside the inside. So that means distribute in my brain. And I don't write the word distribute out. I just draw those arrows. So Savannah said that we're going to multiply. So y minus 8 equals 5 times x is, and 5 times positive 2 is, good job. Now, Bryce, last step. Now we add the 8. Good job. So y equals 5x plus 18. So we've taken an equation that we wrote in point slope form and we transformed it to slope intercept form. We solved for y. I'm going to leave that up there for a second. Good, Jordan. Okay. Does anybody else need more time? Christian, you good up there, bud? Okay. I just want to make sure I had your attention. Perfect. Okay. I'm going to move on to the next one. So example number 3 has a vocabulary word in there. I tried to make it bold for you. Which of the following represents an equation for a line that is parallel to the equation y equals 3/2 x minus 7 and passes through the point 6, negative 8? So I want to talk about parallel lines first because I want to make sure that you remember things about parallel lines. So what do we know about parallel lines? Something that you can tell me. What's equal? They have the same slope. Yeah, good job. That's perfect. Parallel lines, think about parallel lines are lines that never intersect, right? So if you were to take your arms and hold them up like this, I know it sounds silly, but this is how I think about parallel lines, right? I take my arms and I go like this, and the slope, Savannah said they have the same slope. The slope is the way that I slant my lines. Slope and slant mean the same thing. So if the lines are parallel, they're never going to intersect. That means they have the same slope. So parallel lines have the same slope. So now I'm going to put a symbol in there. So I need to find a parallel line that has the same slope as this line. So the slope, M, stands for slope, of my parallel, that symbol, 2 lines together, means parallel lines, has to equal what? We're going to come up with an equation. Has to equal what? I heard you say it, Bryce. Yeah, the slope has to be 3/2 because that's what the slope of this line is. And it has to pass through the point 6, negative 8. Well, we're just going to label that ordered pair x sub 1 and y sub 1. And we're going to plug both the slope value and the ordered pair into y minus y sub 1 equals m times x minus x sub 1. That's your point slope formula. Okay, so I'm going to start calling on people. Lionel, tell me what I'm going to write for the y sub 1 value. Mm-hmm. I would. Y minus negative 8 equals, Michael, tell me what to put for my slope. 3/2 or 3/2. Very good. Times the quantity x minus, Brandon, tell me what to put for x sub 1. 6. Okay, what looks weird in that equation? What looks funky? Yeah, that double negative. What can we do with that? Turn into a great big plus. So what equation matches that? What multiple choice answer matches that? Answer choice 3. How do we feel about that so far? Pretty good? Okay. So there's one more form of a line that we're going to use a lot with systems, which is kind of where we're moving next, right? So last class period, I was told that you guys didn't see this very much in Math 1, or they didn't see it very much in Math 1. The form that we're going to talk about right now is called standard form. Have you guys seen that? Have you seen an equation that looks like this? AX plus BY equals C. If I were to write an example like 3x plus 4y equals 12, have you guys seen something like that before? Yeah, that's called standard form. There's something special about standard form. It says that A, B, and C, those are the coefficients or the constants of the equation. They have to be integers. So I'm going to circle that word, and I need someone to tell me what it means to be an integer. Because I forgot. I forgot what integers are. You guys learned about integers probably in as early as 6th grade, for sure. Integers are unique because they're positive and negative. So an integer can be positive or negative. I'm just going to abbreviate those. Okay. What else? There's something special that makes it an integer. It has to be, can integers have decimals? No. Can they be fractions? No. So it's positive or negative whole numbers. That's what an integer is. It's a positive or a negative whole number. Okay. The second part of standard form is that A and B both cannot be 0. One of them can be 0, but both of them can't. And then the last thing that sometimes we forget is that A, which is my leading coefficient, it's the constant attached to the x, it should be positive. It really should be positive, okay? So this next example is going to take some time. We're going to have to do some manipulating, but we're going to take 2 ordered pairs and we're going to end up turning it into an equation that's written in standard form. So we're going to do it a little bit at a time. We're going to kind of work through the steps. So it says in example 4, you have a line that passes through the points 6, -3 and -4, 12. The first thing that I need you to do is find the slope of the line. So I am going to do the x sub 1, y sub 1 method just because I didn't do it that way on our warm up. Always want to try to present you guys with a couple of options. So the slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you like using the table of values method compared to this, you go right ahead and do that, okay? So my y sub 2 value is 12 minus my y sub 1 value, which is -3, over x sub 2, which is -4, minus x sub 1, which is 6. So the first thing that I'm going to do is get rid of that minus and negative. I'm going to turn that into a great big plus. So I have 12 plus 3, which is 15, over -4 minus 6. And I'm going to show you guys how I think about integers. So I have -4 and -6. Are the signs the same or are they different? They're the same, so I just add them together. That's 10, and I keep the sign. Same signs, add and keep. So I have 15 divided by -10. So I want to reduce that, and I want you to use your calculator to do that. So I want everyone to pick up the calculator that's on their desk, and I want you to take 15 divided by -10. 15 divided by -10. And when you do that, what do you get? -1.5. I want you to write your answer as a fraction. So does everybody see the math button? It's the third button on the left on your calculator. It says math. Do you see it? Math, press it. Press the math button. And when you do that, it has a list of things, and it says number 1, fraction. It's saying to you, hey, do you want your answer to be a fraction? Yeah, I want my answer to be a fraction, so I want you to hit number 1, enter, and then hit enter again. What does it do with your negative 1.5? Turns it into the fraction negative 3 over 2. Okay? I'm going to try to be really intentional about showing you guys things on your calculator. Ma'am. Not right now. Can you wait until we're done? Okay, thank you, dear. All right. Example B. So now we found our slope. Now we have to take that and write the equation in this for this line in point slope form. So we have to make a decision. We know that we're going to use the slope that we just calculated. We have to use one of those ordered pairs. It doesn't matter which one we use. We'll get the same answer either way. You tell me which ordered pair would you like to use. 6, negative 3. Okay. So this is the ordered pair we're going to use, and we're plugging it into this formula. So y minus y1 equals my slope times x minus x sub 1. Thank you, Ms. Durbin. So y minus, well, my y1 coordinate, y sub 1 coordinate is negative 3 equals my slope, negative 3 over 2, times the quantity of x minus my x1 coordinate, which is 6. I always write minus a negative first. I always write it out like that. Because sometimes when you see a minus and a negative, as you're writing stuff out, your brain is like, oh, it's already negative. You don't have to think about that. Do you know what I mean? So I always write it out first, and then I look at them and I change it to plus. So this is the equation in point slope form. Okay, that's our equation in point slope form. Now I have to take that equation and I have to put it in standard form. I have to take that equation and I have to put it in standard form. So I have to make this look like ax plus by equals c. So the first thing that I think we should do is probably distribute. What do you guys think? Do you feel okay with that? So I have negative 3 over 2 times the quantity of x minus 6. I'm going to distribute that. So y plus 3 equals, well, let's see, negative 3 times x is, or negative 3 halves times x is negative 3 halves x. And to multiply fractions, we multiply straight across. Negative 3 times negative 6 is a positive 18. 2 times 1 is 2. What does 18 divided by 2 simplify as? What is 18 divided by 2? It's 9. So I'm going to rewrite this as y plus 3 equals negative 3 halves x plus 9. And I'm going to kind of move it up here. I'm still trying to make it look like ax plus by equals c. What do I have to do next? What did we do to put it in y equals form? If I wanted to get y all by itself here, what would I do? I would subtract 3. So y plus 3 equals negative. I'm just rewriting it really fast. Negative 3 halves x plus 9. I'm going to subtract 3 from both sides. So that gives me y equals negative 3 halves x plus 6. I still need to have the x and the y on the same side of the equal sign, and I don't have that. I need to move that x over to the other side. How am I going to do that? Yeah, I'm going to add 3 halves. I'm going to cancel it out. So I'm going to add 3 halves x to both sides. And remember that the x term, do you see how the x coefficient is first? I want that to come first. So when I do that, I have 3 halves x plus y equals 6. Is that in standard form? Is it? Is a an integer? Is the number attached to x an integer? It's not. How do I get rid of that fraction?
You multiply it all by 2.
Multiply everything by 2. Here's how Savannah thought of that quickly. That's 3 divided by 2, and the undo of divide is multiply. So if I want to get rid of that fraction, I have to multiply everything by the number 2. I have to multiply everything by 2. So 3 halves times 2 gives me 3x. Y times 2 gives me 2y. And 6 times 2 gives me 12. So now I have taken 2 ordered pairs, the 2 ordered pairs that I was given at the very beginning, and I wrote them in standard form. Okay, I wrote them in standard form. So now I want to talk to you about this guy right here. It says, what are the x and the y intercepts? So I know that if I want to find the y intercept, I have to let x equal 0. I know that from the first example that we did. I'm going to tell you that if you want to find the x-intercept, you let y equal 0. Okay? And the way that I do that is called the cover-up method. So I'm going to find the y-intercept first. So that means I'm going to have to let x equal 0. So I have 3x plus 2y equals 12. And I'm going to let x equal 0. And I'm going to just write it right here. What is 3 times 0? So I actually cover this whole thing up. I just don't even look at it. I just cover it up. What equation do I have? 2y equals 12. Divide both sides by 2. Y equals 6. Meaning my y-intercept is 6. So now let's find the x-intercept. And I'm going to do the same thing. I'm going to use the cover-up method. So I have 3x plus 2y equals 12. Well, when I let y equal 0, I have 2 times 0, which is 0. So I just cover the whole thing up. I just ignore it. And that leaves me with what equation? 3x equals 12. I divide both sides by 3. X equals 4. That means that the x-intercept is 4. I'm going to leave that for a second. And I'm going to come up to the board and I'm going to write that equation out and show you how I actually do it on a piece of paper. Because it's not really conducive for me putting my finger on the screen. So 3x plus 2y equals 3x plus 2y equals 12. So when I'm going to find the y-intercept, I cover up the x term, just like that. And I get 2y equals 12, which means y equals 6. When I want to find the x-intercept, I cover up the y term. And that gives me the equation 3x equals 12. That means x equals 4. That's why I call it the cover-up method. Okay? Does that make sense? Did you guys learn that last year or at all? No? Okay, so cover it up. Cover it up. It's a quick way to find your intercepts. Okay? It only works if it's in standard form. It's got to be in standard form for that to work. Okay? But it's a real quick way for you to find out the 2 places that your graph is going to cross the axes. Okay? All right. So, example E says, graph the line of the equation from above using the 2 given ordered pairs. So what were the 2 ordered pairs that we were given to start this whole thing with? We were given these 2 ordered pairs to begin this problem. 6, -3, and -4, 12. So I want you to graph those points first. So you're going to graph the ordered pair 6, -3. And I know that the -4, 12 kind of goes off your graph. You can just kind of eyeball it. That's my -4, 12. And I'm going to just do my very best to draw a line that connects them. It's kind of hard to do that when you aren't all the way on your graph, but that's kind of that's the line, right? If I were to put a ruler up there, it'd be a little bit better, but that's the line from the two ordered pairs that we were given at the beginning of the problem. But we just discovered the X and the Y intercept. We discovered that this crosses the X axis at, well, my X intercept is 4. And it crosses the Y axis at, well, my Y intercept is 6. Did we do that? Did our graph? Yeah. So the question is, like, what do you notice? What do you notice about the two ordered pairs in the X and Y intercepts? Well, they are all on the same line. So all we did was prove that our equation in standard form is the same line as those two ordered pairs. That's all that we did there. We just proved that our equation written in standard form is the same line as those two ordered pairs. Okay. I'm going to go to example 5, and then we're going to stop after this because we didn't get even nearly this far in period 1, and you guys are going to be way ahead of everybody. So example number 5, what type of line does the equation y equals 4 make? Well, do you want me to graph it so you can see it? What does it look like? It's horizontal. Yeah, this is the line y equals 4. This is the line y equals 4. Hopefully you saw this last year. HOY, or last semester. Did you guys see that? HOY, it means that you have a horizontal line. It means that your slope is actually 0. So that O is really representing a 0. And that Y means that your equation is Y equals some number. That's what your equation is. Okay. So if Y equals a number is a horizontal line, what type of line does X equals -3 make? Well, that makes a vertical line. And we hopefully taught you this. Yeah, I heard someone say it, VUX. That means that you have a vertical line. It means that your slope is, what does that U stand for? Undefined. Yeah. Undefined. And your equation is X equals some number. X equals some number.